Hey everyone, welcome to EduTube channel. In this video, we're tackling questions from the CIE Additional Mathematics February 2025 paper, non-calculator version. In question 1, we are asked to sketch the graphs of two absolute value functions. Let's break them down one at a time. Y equals 4 times the absolute value of x minus 1. This is a V-shaped graph. When x minus 1 equals 0, x equals 1. This is the vertex, and the graph is centered at x equals 1. We find y-intercept by substituting x equals 0. Then y equals 4. So the graph passes through 0, 4 and reflects symmetrically across the vertex at x equals 1. Now on to the second function. Y equals the absolute value of 3x plus 2. To get the vertex, the expression inside of the absolute value, 3x plus 2 equals 0. Solving the equation, x equals negative 2/3. So the vertex is at x equals negative 2/3. Again, we find the y-intercept by substituting x equals 0. Then, y equals 2. So it crosses the y-axis at the point where y equals 2. This graph is less steep than the previous one because the coefficient of x is 3. Both graphs should be drawn on the same axis with clearly marked intercepts on both the x and y axes. Now for part B, we're solving an inequality. 4 times the absolute value of x minus 1 is less than or equal to the absolute value of 3x plus 2. To remove the absolute values, we square both sides of the inequality. The inequality holds because both expressions are non-negative. On the left side, squaring 4 times x minus 1 gives 16x squared minus 32x plus 16. On the right side, squaring 3x plus 2 gives 9x squared plus 12x plus 4. Now we move everything to one side of the inequality to simplify. We subtract the entire right side from the left side. That gives us 7x squared minus 44x plus 12. This quadratic expression is less than or equal to 0. We factor this expression as the product of 7x minus 2 and x minus 6. Since the parabola opens upwards, the values of x that satisfy the inequality are between the two critical values, 2/7 and 6. So the solution is x is greater than or equal to 2/7 and less than or equal to 6. That completes part B. In question 2, we're shown a trigonometric graph. Y equals a times cosine of bx plus e. This graph is drawn from negative 180 degrees to 180 degrees. A, b, and c are all integers. Our goal is to find the values of a, b, and c by analyzing the graph. Let's begin by finding a, the amplitude, the distance from the center line of the wave to the peak. Looking at the graph, the highest point the curve reaches is 3, and the lowest point is negative 7. The difference is 10 units. Amplitude is half of the distance between these two values. So the value of a is 5. B is the number of complete waves within 360-degree cycle. In the diagram, there are 3 complete waves within 360 degrees. So, the value of B is 3. Lastly, we find C, which is the vertical shift. We calculate this by finding the midpoint between the maximum and minimum values. The maximum is 3, and the minimum is negative 7. The midpoint between them is negative 2. That means the graph has been shifted down by 2 units. So, the value of C is negative 2. In question 3, we're given 2 points. Point A has coordinates negative 3 and 6. Point B has coordinates 7 and negative 8. AB is the diameter of a circle. Since the line AB is the diameter, the center of the circle will lie exactly halfway between these 2 points. We take the average of x values and y values to find the center. The average of negative 3 and 7 is 2. The average of 6 and negative 8 is negative 1. So, the center of the circle is at the point 2, negative 1. Now we need to find the radius. But for this question, we actually find the square of the radius using the formula for distance squared. We subtract the x values of point A and the center, -3 minus 2. We subtract the y values, 6 minus -1. The sum of the square numbers is 74, so the radius squared is 74. Finally, we write the equation of the circle using the standard form, using the coordinates of the center 2, -1. So, the equation of the circle is x minus 2 squared plus y plus 1 squared equals 74. And that's the final answer. In question 4, p of x is a cubic expression, a times x cubed plus 2a times x squared plus ax plus 2. 2x plus 1 is a factor of this polynomial. That means when x equals -1/2, the value of p must be 0. So we substitute -1/2 into the polynomial. The expression becomes negative a squared over 8 plus 2a over 4 minus a over 2 plus 2. Combining these terms and then multiplying each term by 8, we get negative a squared plus 16 equals 0. Since a squared is 16, we take the a equals 4, which is the positive integer. We substitute a equals 4 into the original polynomial. P of x equals 16x cubed plus 8x squared plus 4x plus 2. We take out the common factor of 2 from the entire expression. That gives us 2 times 8x cubed plus 4x squared plus 2x plus 1. We then factor the remaining cubic expression by grouping the first two terms and the last two. From the first group, factor out 4x squared, and from the second group remains 2x plus 1. Factoring 2x plus 1, we get 2 times 4x squared plus 1 times 2x plus 1. That's the fully factorized form. Now we're asked to show that the equation p of x equals 0 has only one real root. Look at the expression 4x squared plus 1. Since x squared is always non-negative, 4x squared is always 0 or more. Adding 1 means this part of the expression is always greater than or equal to 1. That means 4x squared plus 1 is never 0, and it has no real solution. Therefore, the only real solution is x equals -1/2, and that completes question 4. In question 5, we are asked to write the given quadratic equation in the form. To express in the given form, first factor out the 2 from the first two terms. 2 times x squared minus x and plus 3. Now we complete the square inside the bracket. Take half of the coefficient of x, which is -1/2. The expression can be written as 2 times x minus 1/2 squared minus half squared and plus 3. Now distribute the 2. That gives us 2 times x minus 1/2 squared minus 1/2 plus 3. Simplifying, the expression becomes 2 times x minus 1/2 squared plus 5 over 2. Now f of x equals 2x squared minus 2x plus 3. From part A, the vertex occurs at 1/2, 5 over 2, which is the minimum value since the quadratic graph opens upwards. To make the function 1 to 1, we must restrict it to one side of the turning point. So the greatest value of p for which the function has an inverse is 1/2. Now we find the range of the function f. When x equals 1/2, the corresponding y value is 5 over 2. Since the parabola opens upwards, the range of f is f of x is greater than or equal to 5 over 2. Now, for the final part, we can use the function in completed square form and swap x and y. To get the inverse function, we rearrange this to make y the subject. First, subtract 5 over 2 from both sides. Now divide both sides by 2. Then, take the square root of both sides. Finally, add 1/2 to isolate y. This gives us the inverse function. F inverse of x equals 1/2, plus the square root of half times x minus 5 over 2. And that completes question 5. We are given that tangent of theta is equal to the square root of 5 divided by 5, and that the angle is between 180 degrees and 360 degrees. Thus, the angle is in either the third or fourth quadrant. Since tangent is positive, theta must be in the third quadrant. We can now build a right-angled triangle using the tangent ratio. Tangent is the ratio of opposite and adjacent sides. When the opposite side is square root of 5, and the adjacent side 5. To find the hypotenuse, we use the Pythagorean theorem. The sum of the square of the sides is 30. So the hypotenuse is the square root of 30. Now, cosine is adjacent over hypotenuse, and in the third quadrant, cosine is negative. So the value of cosine theta is negative 5 over the square root of 30. Now let's find the value of sine theta. Sine is opposite over hypotenuse. In the third quadrant, sine is also negative. Using our triangle, the opposite is the square root of 5, and the hypotenuse is the square root of 30. So sine theta is negative square root of 5 over square root of 30, which is equivalent to negative 1 over the square root of 6. Next, we need to find the value of secant theta plus cotangent theta. Secant is the reciprocal of cosine, negative square root of 30 over 5. Cotangent is the reciprocal of tangent, 5 over square root of 5. To express this in the given form, we rewrite the square root of negative 30 over 5 as negative square root of 6 divided by square root of 5. The sum of the expression becomes 5 minus square root of 6 divided by square root of 5. Question 7 shows a diagram which includes a curve with the equation 5 divided by x plus 1 plus 2. The curve intersects with a straight line given by 2x plus 1. We are asked to find the coordinates of the intersection point, labeled A. To do this, we equate these two equations. 2x plus 1 equal to 5 over x plus 1 plus 2. Subtracting 2 from both sides gives 2x minus 1 equals 5 over x plus 1. Now we eliminate the fraction by multiplying both sides by x plus 1. On the left-hand side, 2x squared plus x minus 1, which equals 5. Subtract 5 from both sides to get the quadratic equation. Now we factor the quadratic. 2x minus 3 times x plus 2. Setting each factor equal to 0, there are two values of x, 3 over 2, and negative 2. Only the value x equals 3 over 2 lies within the visible range of the diagram. Now we substitute this x value into y equals 2x plus 1, which is 4. So the coordinates of point A are 3 over 2 and 4. We are now asked to find the exact area between the curve and the line. The region starts from x equals 0 to x equals 3 over 2. To find the area, we subtract the lower function from the upper one and integrate over the given interval. So the area is given by the integral from 0 to 3 over 2 of 5 divided by x plus 1 plus 2 minus 2x plus 1 with respect to x. We simplify the expression inside the integral, 5 over x plus 1 minus 2x. Now we integrate term by term. The integral of 5 over x plus 1 is 5 times natural logarithm of x plus 1. The integral of 1 is x. The integral of minus 2x is minus x squared. We now evaluate the expression from 0 to 3 over 2. Substitute 3 over 2, we get 5 times natural log of 5 over 2 plus 3 over 2 minus 3 over 2 squared. Substituting 0, we get 5 times natural log of 1, which is 0. We can simplify that to 5 times natural log of 5 over 2 plus 3/4. This is the exact area of the shaded region. In question 8, there are two number patterns are involved. One is a geometric progression, and the other is an arithmetic progression. The first terms of both geometric progression and arithmetic progression are 10. The second term of the geometric progression is equal to the fourth term of the arithmetic progression. That means 10r is equal to 10 plus 3d. Next, the third term of the geometric progression is equal to the sixth term of the arithmetic progression. That means 10r squared is equal to 10 plus 5d. To eliminate d, multiply both sides of the first equation by 5, and multiply both sides of the second equation by 3. Subtracting the second equation from the first, we get 50r minus 30r squared equals 20. Subtract 20 from both sides, and then divide everything by 10. We get 3r squared minus 5r plus 2 equals 0. This is a quadratic equation. It factors into r minus 1 times 3r minus 2 equals 0. So the two possible values are 1 or 2 over 3. But the question states arithmetic progression must have a negative difference. If r is 1, 10 equals 10 plus 5d. d would be 0, but d must be negative, so r equals 1 is not allowed. Now let's try r equals 2 over 3. Now plug this value into the formula for d. Rearranging 10r squared equals 10 plus 5d, we get d equals 2r squared minus 2. Substitute r equals 2 over 3, and solving the expression, the value of d is negative 10 over 9. For part b, we use a simple rule. For a geometric series to have a sum to infinity, the common ratio must be between negative 1 and 1. r is 2/3. That is between negative 1 and 1. So the geometric progression have a sum to infinity. In question 9, we are given that the logarithm base 2 of x plus 1 minus 4 times the logarithm base x plus 1 of 2 is equal to 3. We can make it simpler by using a substitution. Let's say the logarithm base 2 of x plus 1 is equal to y. Then the logarithm base x plus 1 of 2 is equal to 1 over y. Now, let's go back to the original equation and rewrite in terms of y. It becomes y minus 4 divided by y is equal to 3. To remove the fraction, we multiply everything by y. This gives us y squared minus 4 is equal to 3y. We then rearrange the equation to bring all terms to one side. Y squared minus 3y minus 4 equals 0. Factor the quadratic expression y minus 4 times I plus 1 equals 0. This gives us two possible values, y equals 4 or y equals negative 1. We have assumed that y is the logarithm base 2 of x plus 1. If y is 4, then x plus 1 must equal 2 raised to the power of 4, which is 16. That means x is 15. If y is negative 1, then x plus 1 equals 2 to the power of negative 1, which is half, so x would be negative half. This completes question 9. In question 10, point P lies on a curve y equals 5x plus 2 raised to the power of 2/3. The x-coordinate of point P is 5. To start, we find the full coordinates of point P. Substitute x equals 5 into the curve equation. So 5 times 5 plus 2 is 27. 27 is 3 cubed. Solving the expression, we get y equals 9. So the coordinates of P are 5 and 9. To find the gradient of the curve at point P, we need to differentiate the equation of the curve. Using chain rule, the derivative becomes 2/3 multiplied by 5, and then multiplied by 5x plus 2 raised to the power of negative 1/3. Plugging in x equals 5 again, and after simplifying, the final gradient of the curve at point P is 10 over 9. Now, we want the gradient of the line that is normal to the curve at that point. For perpendicular lines, the gradient is the negative reciprocal. So, the gradient of the normal line is negative 9 over 10. Next, we use the point slope form to write the equation of this normal line. We already know the gradient is negative 9 over 10, and that it passes through the point 5, 9. This gives us an equation of the form y minus 9 equals negative 9 over 10 times x minus 5. This normal line intersects another line, which is given by x plus y equals 11. To find the intersection point, which we call point Q, we solve these two equations together. First, we substitute y equals 11 minus x into the equation of normal line. After careful step-by-step calculation, we find that the x-coordinate of point Q is -25. Then the y-coordinate is 36. So point Q is at -25, 36. Finally, we are told that point R is the reflection of point Q across point P. Since P is the midpoint of Q and R, we use the formula for the midpoint. Using the coordinates of P and Q, we solve to find that the x-coordinate of point R is 35. And using the same reasoning, we find the y-coordinate is -18. So, the final answer is that point R is at 35, -18. In the given diagram, the position vector from point O to point A is called A, and the position vector from point O to point B is called B. Point M is the midpoint of the line segment OB. This means the position vector from O to M is half of B. Point N lies on the line from O to A. The vector from O to N is 3/4 of the way from O to A. So, the position vector from O to N is 3/4 of A. Now, let's look at point X. It is the intersection point of two lines, line BN and line AM. Vector BN is ON minus OB, which is equal to 3/4 times A minus B. Bx is lambda Bn. So Bx equals 3/4 lambda A minus lambda B. Similarly, vector MA is OA minus OM, which is equal to A minus half B. Since Mx is mu MA, Mx equals mu A minus half mu B. From O to X, we go from O to B, then from B to X. So vector OX is equal to B plus 3/4 lambda A minus lambda B. Next, from O to X, we go from O to M, and then from M to X. In this case, vector OX is equal to half E plus mu A minus half mu B. To find the value of lambda and mu, we compare the two expressions for vector X from parts A and B. Now we match the terms for A and B. Let's start with the coefficient of vector A. 3/4 times lambda equals mu. For the coefficient of vector B, 1 minus lambda equals half minus half mu. Now solve these two equations. Substitute mu equals 3/4 lambda into the second equation, and we have 1 minus lambda equals half minus 3/8 lambda. Solving this, we find that lambda equals 4/5. Now substitute this value of lambda into the first equation to find mu. So mu equals 3/4 times 4/5, which gives 3/5. So lambda is 4/5 and mu is 3/5. Question 12 involves differentiation and integration. We are given a function, y equals x times e to the power of 3x plus 2. In part A, we need to find the derivative of y with respect to x. Since y is a product of two functions, x and e to the power of 3x plus 2, we use the product rule for differentiation. The derivative becomes x multiplied by 3 times e to the power of 3x plus 2, plus another term which is e to the power of 3x plus 2. That gives us our final expression for the derivative of y. In part B, we are asked to find the integral of x multiplied by e to the power of 3x plus 2 with respect to x. To solve this, we make use of the result we just found in part A. We can rearrange this result to help us find the integral. Integrating each expression 3 times the integral we want is equal to y minus the integral of e to the power of 3x plus 2. Y is x times e to the power of 3x plus 2, and the integral of e to the power of 3x plus 2 is 1/3 e to the power of 3x plus 2. Then divide everything by 3 to isolate the integral. This gives us the final result, which is 1/3 x times e to the power of 3x plus 2, minus 1/9 e to the power of 3x plus 2, and we add a constant of integration at the end. This completes question 12.